All right, welcome back, Marauders. Section 4.2 is about precipitation reactions, sometimes also called double replacement reactions. So to understand what's going on in a precipitation reaction, you need to understand a little bit about solubility. So some salts dissolve in water, meaning that they can turn completely into ions and they go into the solution. And other salts do not dissolve in water, meaning that they're going to stay as a solid. They're going to stay as crystals, they're going to sink to the bottom or make the solution look cloudy. The solubility rules that you need to know for the AP test are just that salts containing the alkali metals, so alkali metals are going to be lithium, sodium, potassium, rubidium, cesium, and francium. So any of these alkali metals, if they're in a salt like lithium chloride or potassium nitrate, anything that has one of these ions in it is going to dissolve in water, always. So the alkali metals, ammonium, which is NH4 and has a +1 charge. So any ion that has ammonium in it as part of it is going to dissolve. And anything that contains nitrate, NO3 with a -1 charge, is always going to be soluble. It's always going to form an aqueous solution containing ions anytime it contains one of these three things, the alkali metals, ammonium, or nitrate. Now, other salts may or may not dissolve in water. There's a whole list of solubility rules in your book. You no longer have to memorize those for the AP test, so it might be useful to look at those when you're trying to answer some homework questions, but you don't need to memorize those rules other than alkali metals, ammonium, and nitrate, always going to be soluble, any salt that contains those. So a precipitation reaction or a double replacement reaction, is a reaction where the formation of an insoluble salt occurs. So we're going to start with two aqueous solutions. So this is sodium chloride, which dissolves in water. We put AQ after it to mean that it is soluble and that it's present as ions. And silver nitrate, also an aqueous solution. So this would be present in a solution as silver ions and nitrate ions separate from each other. All right, so we're going to have a double replacement reaction take place. So what that means is that the cation, the positive ion from here, is going to go over and pair up with the anion, the negative ion from over here. So we have sodium pairing with nitrate, so it'll make sodium nitrate. And then we'll have the cation from here pair up with the anion from here. So we'll have silver pairing with chloride, AgCl. Remember, when you're writing these, you always want the cation to be listed first, so I don't want to put chloride silver. It has to be silver chloride. Okay. Now, by knowing my solubility rules a little bit, I know that this one has an alkali metal and nitrate in it, so I know this one's going to be soluble. I'm going to put an AQ after it to mean that it's aqueous, to mean that it does dissolve in water. And then silver chloride, if I do consult the rules in my book, or if I know my solubility rules a little bit, I know that this one's insoluble. So things that are insoluble get an S after it, meaning it's going to form a solid. When you do this reaction in the lab, you're going to see two clear solutions, two solutions that are completely transparent and look just like water. You can't see any of the ions. You pour them together, and it's going to become cloudy. There's going to be a solid forming, and that solid that forms is going to be the silver chloride because it is a solid. It doesn't dissolve in water, and so it recrystallizes and eventually will sink to the bottom. Okay, so that would be the reaction that's taking place. Typically, with the double replacement reactions or the precipitation reactions, we can write ionic equations. So since these things are present as ions, it's not really silver or sodium chloride when it's in solution. It's really sodium ions and chloride ions. And then the silver nitrate, also aqueous, so it's really silver ions and nitrate ions. And when these things react together, they really make sodium ions and nitrate ions and silver chloride, which is a solid. So this one I'm going to leave together because it's not present as ions. These I wrote out, I broke these all apart because when they dissolve in water, they do dissolve and they do separate from each other and move around independently. But the silver chloride stays together as a solid. So this one will be written as AgCl, and that one will be a solid. So that's your complete ionic equation. It shows everything that's present as ions. And next what we're going to do is write what's called a net ionic equation. So if you'll notice in this equation, you have some things that are present on both sides and didn't change. So you have sodium ions here and sodium ions here. And so since the sodium was unchanged, you can cancel it out. So on both sides of the equation, it really didn't undergo any kind of reaction. It's actually called a spectator. A spectator ion is one that doesn't change, it just happens to be there, and it just kind of watches the reaction take place. The other spectator we have is the nitrate. So we have nitrate ions present on both sides. They didn't change. There were ions here and ions here, so they didn't change. So we can cancel those out. And when we do this, we get something called the net ionic equation. So the net ionic equation is just going to be that chloride reacts with silver to make silver chloride. So all that's happening in this reaction is that chloride ions are attaching to silver ions to make silver chloride. And you have these two aqueous ions combining to make silver chloride. So you can write it out three different ways. The most useful way is probably just the net ionic equation, because that shows what's really taking place. Okay, nothing, the nitrate and the sodium really weren't involved. There could have been any other ion there and the same thing would have occurred. Let's do one more example. So this one is with aluminum chloride and potassium sulfide. All right, so let's put these together. So the aluminum can't pair with the potassium. It has to pair with a metal with a nonmetal, or a cation with an anion. Okay, so these two are going to pair up. On this one, we have to think a little bit more about the charges. In the last one, it was easy because everything was +1 or -1. But here we'll think about the charges. Aluminum is always a +3 charge. Sulfide is a -2 charge. So when we put these together to make aluminum sulfide, it has to be Al2 S3. Okay. And then our other pairing is going to be the potassium with the chloride. Potassium's a +1 charge, chloride's a -1 charge, so when I put those together, it's KCl. All right, so knowing my solubility rules a little bit, we see an alkali metal right here. We know alkali metal's always going to be soluble. So since it's soluble, we'll put AQ after it, meaning aqueous, that it does dissolve and breaks apart into ions. And then if you do look at the solubility rules a little bit, you'll see that sulfides are typically insoluble. There's a couple exceptions, but most of the time, things that contain the sulfide ion are going to be insoluble. So that'll get a little S after it because that's going to be the solid that forms. And so that's what's taking place. We can go back at the end and balance this one. So since we had 2 aluminums on this side, we need to put a 2 here. And then since we have 3 sulfurs here, we need to put a 3 there. And then we have 2 times 3, so that's 6 chlorines. 3 times 2, so that's 6 potassium. So we'll put a 6 right there to balance this equation. So write out all the formulas correctly first based on the charges of the ions, then go back and add the coefficients to balance it. All right. When I'm writing my ionic equation, I'm going to write out, remember, anything that's aqueous, anything that's present as ions, I'll write as ions. So I'm going to make silver ions, aluminum ions, the +3 charge, and chloride ions with a -1 charge. And then you'll have potassium ions, and you'll have sulfide ions. And when those react together, it makes the solid. So since this is a solid, I don't break it up into ions, I leave it together as a compound. So Al2S3, which is a solid. And then potassium chloride is aqueous. So potassium ions and chloride ions. All right, and then for our net ionic equation, we can cross out anything that's a spectator, anything that didn't change between the reactant and product side. So we have potassium ions on both sides, we have chloride ions on both sides, so they cancel out. And so really that all that's happening in our net ionic equation is that the aluminum with a +3 charge is reacting with sulfide with a -2 charge to make aluminum sulfide. So we have 2 aqueous ions, and they react together to make this solid, and then we can balance this. So when we balance this, we just need a 2 in front of the aluminum because there's going to be 2 there, and we need a 3 in front of the sulfide.